All right, today we're going to look at properties of logarithms. We're going to talk about how exponential functions and logarithmic functions are inverses of each other, and then we're going to develop two different properties of logarithms. So first we're going to look at the graph of the exponential function, and just as an example, we're going to go ahead and look at f of x equals 2 to the x. So I'm going to ask that you go ahead and graph that using at least 5 critical points. By critical points, I mean probably 0, and then to make sure that that y-intercept, and then a couple points on either side. So we're going to try -2, -1, 0, 1, and 2. So as we graph that, as I graph 2 to the x, then I'm going to say 2 to the 0 is, of course, 1. Right? And 2 to the first is 2. And 2 squared is 4. Right? When I say 2 to the -1, that's 1/2, so I'm doing my best to approximate halfway. 2 to the -2 is 1/4, so half of that again. Right? That's quite enough to be able to get that. It says at least 5 critical points. If you want to do 3, 8, that's 4, 5, 6, 7, 8's going to be right up here, right? To make sure that you keep that exponential trend happening. And then we'll connect those dots. Right? Make sure we're approaching that asymptote. Here we're going up, up, right? That's going to be f of x equals 2 to the x. So if I'm looking at this graph, I can state my domain and range. My domain, we know this keeps going infinitely to the left and infinitely to the right. So my domain is going to be all real numbers. And that's interval notation for my all real numbers. Make sure if you're using set builder notation, you're doing x such that x is an element of the real number system. That's that double script r. Right? My range, I know I'm going above this asymptote, above 0 here. So I'm starting at 0 and going up towards infinity. Reminder that I always am increasing. I'm not including the 0, and of course I can't include infinity. If I did that in set builder, y such that y is greater than 0. Right? So make sure we're comfortable using both. I often do go to interval as my go-to. My asymptote, of course, my horizontal asymptote is all I have, which is y equals 0. My vertical does not exist, right? I have no vertical asymptote. Now it says to graph the inverse of that function, and then says, is it also a function? So we know the inverse is flip the x and the y. So actually my range becomes my domain, right? So my range, I know, is going to be 0 to infinity. I know my domain 0 to infinity. My range is going to be all real numbers, right? I know that piece going in. I know that I should not have a horizontal asymptote, but I should have a vertical. Again, y becomes x. I know this part already should be happening, right? I'm going to go ahead and draw in that asymptote here. I forgot to do that a moment ago. Right? Again, you can't really tell since it's on the axis, but I can see that's y equals 0. Right? Notice again, I'm using different colors just so I can differentiate. So now if I graph the inverse, again, I flip the order of my ordered pair. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 1, 2, 3, 4, 2. Again, I could do 5, 6, 7, 8, 3 if I really wanted to get that curve going still. Can't really see that one. -1, 1/2 becomes 1/2, -1. -2, 1/4 becomes 1/4, -2. And as I connect those dots, again, we're going to see it approaching this vertical asymptote. Right, this vertical asymptote here at x equals 0. And as I connect these dots, this is going to be f inverse of x, whatever that function may be. And of course, what we know to be true about inverse functions, it really does reflect across this line, which hopefully we remember. Right? I like to draw it dotted since it's not really a part of either of these functions. But this y equals x line, right? Again, I'm going to draw it dotted here. Notice how I'm drawing that y equals x line is that I'm actually going at the corner of each square, right? Rise 1, run 1, rise 1, run 1. Right, so y equals x. Notice if I tried flipping this over that line, they would look like the same. So this is actually the curve of my inverse function to this exponential. And as we proceed through, we're going to remind ourselves of the definition of a logarithmic function, right? And we're going to recognize this really, since exponentials and logarithms are inverses of each other, this green graph must be the graph of a logarithmic function.